The sides of a triangle are 17 centimeters, 144 centimeters, and 145 centimeters. What is its area? Before we start, I suggested to try this one first on your own. Okay, good. So let's begin. So usually our first instinct here is to use, if you know, what we call the Heron's formula. So Heron's formula is basically a way to compute the area of a triangle given all of its sides. The problem with that is that it's very tedious, and questions like these are usually for competition problems, math competition problems. So that isn't the most efficient way to solve this. So to give you another insight on how to solve this, we start with the following first step. So for problems like this, the first thing to do is to observe and try to observe if there is a certain pattern out here. And what do I mean by that? In these given numbers, what is something interesting that we can find out here? Well, take note that 144 and 145 are consecutive numbers. So let's take note of that one. So in here, let's take note that 144 and 145 are consecutive. Now, what's interesting with having consecutive numbers? Let's write this as a and let's write this as b. So we'll have here a squared and b squared. When you see these two, we usually associate it, if we add a minus here, with difference of two squares. So that's actually one of the insights that we can obtain from this. So let's put it out here. So let's write difference of two squares. So for now, let us just take note of that insight, and let's proceed with the next step. In terms of area of triangles, rather, what is the easiest to obtain its area from? What kind of triangle is that? Well, if you don't know, the easiest to obtain is a right triangle. So this is what we will be checking, if this thing is a right triangle. Because if this is a right triangle, then that's the area of that one would be easy to get. So here, recall that in a right triangle, so let's draw one here. If the sides are given by A and B, then we have its hypotenuse to be given by usually C. And we know that by a special theorem that we can use here is the Pythagorean theorem. In a nutshell, the Pythagorean theorem states that given this right triangle out here, then we have the following relationship. A squared plus b squared is equal to c squared. Now, so far, our insight involves possibly with difference of two squares. So how do we obtain a difference of two squares out here? Well, the trick is to move one of these to the other side. Let's move b. So if we move b out here, then we will obtain c squared minus b squared equal to a squared. I just flipped the equality. This is possible, of course, by symmetry of equation. Okay, we have a difference of two squares. So let's check what will happen if we subtract this one. So we'll have here, let's just put let's check. So checking, we will be having 145 squared minus 144 squared. We know that by algebra, or algebraic manipulation, this is just equal to 145 minus 144 times 145 plus 144. Simplifying, this is just equal to 1 times 289. And this is where the magic comes in. 289 is just actually equal to 17 squared. And this is the relationship that we want. As we can see, 145 squared minus 144 squared equal to 17 squared. Or in other words, these three numbers satisfy the relationship for the Pythagorean theorem, and in turn must mean that these three are a Pythagorean triangle. So we have here that we have a right triangle. So this is good. This is easy to get. The area of this, the triangle that we have is easy to get now. So we just compute for the area. Recall that in area of a right triangle, just assume that this thing here is a right triangle. It's just given by 1/2 times base times height. In our case, the base here, this will be given by 145. Oops, I'm wrong about that. It should be 144. And this here will be given by 17. So computing for that one, we'll have your 1/2 times the base is 144 times the height is 17. Simplifying, these two will just cancel out to 72. So we'll have here 72 times 17. And you can check that this will just be equal to 1,224 square centimeters. This is the answer for the following problem. So I hope you enjoyed that one. This is a nice trick for areas of triangle instead of like a tedious computation. The key is to observe a pattern, and that is consecutive numbers out of it. Usually math competitions doesn't just provide random numbers. They instead provide numbers wherein there's some meaning into it. Also, another key insight here is that take note that the difference of two squares is always an odd number. So that's another insight that you can obtain from this, because 17 is an odd number. So usually two squares will have consecutive one, and then the third one hopefully must be odd, so that there's a high chance that this technique would work. And then from there, just verify that it is indeed a right triangle. Then once you are sure about that, its area is easy to get. So yeah, I hope you enjoyed that one. If you have any suggestions, feel free to comment that one down below. Besides that, have a nice day.